hopefully everyone's not sleepy now after lunch, and because it's going to be a little different from the previous topic, it's more about AI, LLMs, and model context protocols. I'm Yash. I am a Google developer expert in cloud and AI, and I also work at a consulting company called Vivanti. I primarily focus on data engineering, data platforms, and machine learning and AI engineering projects. What I'm going to talk about today is model context protocol. Who has heard of MCP before? Look, who has used an MCP before? Very few. And who has built an MCP server before? Even less. So don't worry, it's not a problem. It was released less than a year ago. So it's still emerging. It was introduced last year by Anthropic as an open protocol to allow tools to communicate with LLMs or agents, whatnot. So less than a year old, but everyone has been fond of it. LangChain and LangGraph followed in less than 3 months with their support for MCP. All of LangGraph, LangChain modules support MCP. In April, Google announced that Gemini modules support MCP, and they also released ADK. I don't know the exact date, but it was somewhere around the next conference when they announced that. Windows announced the support, saying, okay, we are in support of MCP. It is like USB-C for your AI apps. So you can use the same interface for different apps to communicate with different kinds of tools without you necessarily needing to customize your access. So a lot of people, a lot of companies have been adopting it. Again, Gemini, so it was in May when Gemini released their native support to MCP. Figma, interestingly, announced MCP servers for their applications. So LLMs can design Figma apps for you. I haven't tested it myself, but it's out there. There was an MCP registry that was released earlier, a month ago, where it's like a Docker hub where people can host their own MCP servers, have all of them in the same place. And just 15 days back, Google announced that they're open sourcing MCP server for ads. So AI can work with Google Ads data. But what's the fuss all about? Why is everyone building MCP servers? And as we discussed, it gives a common standard for agents and LLMs to interface with tools. And when I say tools, it could be any programming language, any format, and any end system. It could be your CRM, it could be, as you saw, ads data, it could be Figma, anything, without you needing to write custom interface to for your LLM to interpret what's the format of the tool. MCP just gives a common layer of allowing that interface. Sorry. But before we go into that, what is an agent? Agent has a model, which is an LLM. It has some instructions, it has some tools, and it can also have access to sub-agents. This topic, we're going to talk about tools. But what do tools do? So your tools can interface with your CRM. They could interact with your finance systems, could interact with your marketing systems. You could have your internal knowledge base in databases or file systems, wherever it is. So tools let you access all of those systems. Sorry, not you, but your agent access to those systems. That sounds pretty easy, right? I could just write Python or JavaScript or Java code functions, and off we go. My agent now has access to everything. Sounds easy. It is, right? No, it's not. It's not just usually one agent that you'd be dealing with as you start scaling. There'll be a new agent that comes in, which accesses some tools that are the same, but there's some new tools now which it needs, for example, sales in this case. Let's say there's another agent which has a different set of tools that it needs to perform the task. And as an enterprise you keep growing, you would have hundreds and hundreds of agents over time, each of them trying to access a different version of the tool. So for me, when I'm trying to access CRM, my definition for a customer could be different versus what you interpret the definition of a user would be. What if we could combine all of that as a single source of truth, that everyone would access the same data in the same manner? But not just that, what about performance? As we saw before, all of the tools were on the same compute as your agent. So now, if I get a million requests, all of those tools would be running in the same shared resource pool as your agent. Is that good? A lot of people here are from software background, I imagine, and you'd know that microservices were invented to tackle this problem. What if we could decouple the agent runtime from your tools? So your tools could be sitting somewhere on a different server, and your agent could call the server over a standard protocol. So your tools are here on a different bunch of compute services sitting somewhere, you don't know where. But they sit somewhere, and your agent can just ask it to give you that information that it needs or perform an action for you. So what if your agent needs to communicate with Google Drive or send a calendar invite out based on a request? You don't necessarily need to have all of the logic sitting here on your compute, but could be sitting somewhere else. And even a step further, all of your tools that are related to a different set of systems, not all CRM, different set of tools, they could be on a different server. So a team who owns your CRM, a team who owns finance data, there's a team who owns your marketing data. In any enterprise, you would know there'll be teams who own a bunch of data. What if they could host their own MCP servers or host their own tools that can be accessed somehow? And again, that's where MCP helps you. It allows you to separate your agent from tools. And it's not that it does it out of the box. You need to architect your applications, your systems in a way that your tools can be hosted remotely. And it's not as easy as you think. But before we jump into how tools are defined, what else does MCP provide? It's not just tools. It gives you access to prompts. So you can have a centralized repository of prompts. Imagine you are a finance company and you want to have a standard set of instructions for your agents that serve your customers. So they all can have a singular shared set of prompts that can be versioned and controlled over time so that they all can be on the same platform. As another example, you could have a prompt or set of instructions that is to summarize my meeting, so plan a vacation. So the users don't need to instruct it every single time, but they could have a shared template that can be reused against all of your interactions. And they all can be version controlled. The other thing that we see here is a resource. And resource is very similar to a tool, but it's how you access data. So it's just a technical separation of your tools is if you access data, then it's a resource, otherwise it's called a tool, which does an action. And tools are usually controlled by a model. When I say that, it's what tool do I, when I, as an LLM agent, what tool do I need to help the user? So if the user is asking to set up a meeting with people on my organization who are working on this project, it can go and look at the schedules of every single person who I want to set this meeting with, and then create a meeting invite. So that creation aspect of it can be a tool versus the data that is retrieving the information about the schedules is a resource. And that can be controlled at the application or your front end. So when you start defining what session it is, what user is trying to achieve something, that data can be loaded by the application and then passed on to the model so that it can use that to perform an action. Does that make sense? Yes, very good. So MCP provides a dynamic discovery of your tools, prompts, and resources. So if your server is sitting somewhere and your finance team updates your tools or your prompts or your templates, they instantaneously get updated by on your agent metadata. So your agent, so every time that your agent starts an interaction, it calls the MCP server to identify what tools do I have access to, what resources do I have access to, what prompts do I have. If something got changed there, it will get reflected in real time. So essentially, it's more dynamic discovery rather than you defining the prompts up front or your tools up front. So I'll show an example of how that update works during the demo. But just think of it in this way, that sorry, you don't need to update the tools on the agent definition. It can be updated remotely. And when you think of this in terms of an enterprise, it makes a lot of sense because your agents can be defined by people who are not owning the data all the time. It's like your finance team owning this data set, your marketing team owning a different data set. They define how people access, but your agent can define what tools can I access based on that MCP definition. So it's dynamic. A lot of people said that they used MCP Server. How many of you used MCP Server with Gemini CLI or Claude Code or Codex? Yes. And did you inspect the mcp.json file? What did you see? Was there a command or was there a URL? Yes. So there was an npx command or a uv command that runs that server locally on your device. So that's a standard input-output method of communicating with your server. So what it does is when you run npx or uvx command, it actually pulls that server, literally the code, onto your machine. It runs that server on your machine, and then your clients can interact with that server with stdio inputs with uvx or npx commands that, okay, use this tool, use that tool, and it's all over stdio. And this is really good when you're developing locally or it's your developer assistant that runs on your machine. But as we talked before, as we think about scaling where you're serving thousands or millions of customers, it doesn't scale as much because everything sits there. All of the tools come to your agent and every execution needs to trigger that server every single time. The other way is remote MCP server. So it could be over HTTP or something called SSE, which is called server-side events. So what this architecture allows you to do is, again, separate a client and server, and it communicates over HTTP with the JSON RPC 2.0 format, which is, again, a standard that MCP uses. And most of the tools that you've used before, you could host them on a separate compute. So you could share that resources amongst your organization for them to run those tools in a shared environment. So it could be GKE or something like that, where you host all of your tools or Cloud Run and host all of that there. And your clients can just pass on a request, not execute it there, but pass on a request that please do it for me. It does it and responds back with outputs. Any questions? Yeah. Okay. Demo time. So a lot of theory, but it's time for a demo. In this scenario, I'm going to use Python for a MCP server. I'm going to define two different servers. One is a local stdio server, and the other one is an HTTP server. And defining a server with fast MCP is pretty easy. I've defined a couple of tools. One is called add numbers. I know LLMs don't need it, but let's define them. The other one is for subtracting, and the third one is for multiplying numbers. And what I've done is I've tagged all of them as a local server tool. So when I turn on my local server, my agent would have access to these three tools. Is it visible on the back, or should I zoom in a bit more? Better? And what I've done is for my remote server, I've added three different uh, functions. I was lazy. I just called them say hello to, and greetings. Um, they do essentially the same thing. I just wanted to show how that dynamic discovery of tool works. Let's have just two tools in this scenario. So my server would only have two tools. My remote server would have two tools, say hello and say hello to. And turning my server on in the HTTP mode does something. It would turn on the server and my local host, 4200. What I'm going to do along with that is define an agent and say it has access to HTTP MCP toolset. I haven't defined what tools can it access. I've just defined that this is an MCP server that hosts these tools. Use it to achieve the task. I haven't defined what tools should it run. And if you look at the definition, it's just looking at the localhost slash MCP. That's it. My agent, I haven't defined any tool for my agent here when I'm defining it. So if you imagine this case for your non-technical teams where they want to build AI applications without the need of know-how or how do I interact with each and every database, it could be taken care of the tech teams, whereas the business teams can just define that these are the tools I have access to, and I can give it an instruction set. So with the HTTP, um, oops, yeah, it is here. So as you see, there's an MCP agent that I've defined, and as we saw, there's no tools, but I can still go ahead and ask it. It says I have two tools, say hello and say hello to. Now, I will not turn off my agent. I'll keep my agent up and running here. What I'm going to demo is I will change my server code and bring this tool back. Oops. And I'll turn on the server again. So now, if we go here, and as you saw, I haven't turned off my agent yet because it doesn't need to, because the server refreshed all of the tools. Yes. So it say hello to, and greetings came up without me needing to turn off my agent. So if your business teams have defined an agent that is consumer facing, it never needs to go down. The backend tools can be refreshed and reused by your agent without needing to have a full deployment process on your agent. But what if I needed some tools that were very specific for my agent, which are not used by everyone else, but I still need them and I don't have any servers sitting somewhere? Can I use both remote connection as well as a local connection? And the simple answer is yes. You could just define both of them as local MCP toolset, HTTP toolset. It's a random naming. You can call it anything. But the local naming is I run a UB command here, which is run the server in stdio mode. And I'm still connecting to my remote, which is locally hosted. And now if I update my agent, it came up with these new tools as well: subtract, multiply, say hello, to greeting. So it now uses both remote as well as the local tools to achieve what it needs to achieve. Just as a freebie, if you like inspecting how the tools were called and whatnot, you can just a random example. So if you that it said say hello, what it did was when calling the say hello tool, it said pass on GDG Brisbane as a parameter, even though I haven't defined it anywhere here. My server controls what the LLM needs to do. It's passed on GDG Brisbane and then hello GDG Brisbane. And you can inspect all of your tool calls. So this is what you passed on as input. This is what you got back. What if I wanted to define a tool without MCP? Can I do that? Yes. So what you could do is just define a function here. And you could use that tool here. And your agent would still be able to identify which tool sits where and what do I need to do to call those tools. So now it identified with MCP remotely, I can call these three tools. Locally, I have these tools. And this is an in-memory defined function, which is here, which I can call it with these parameters. Does that make sense? Anyone has any questions on that? Yes.
Well, actually building on the two sets, right? Is that the best? It's just a best practice to descriptions of two. Let's say one is a function, one is a description of the input parameters and output.
Yes. So the question was, is it a best practice to define descriptions for your functions and your input parameters and output as well, by the way? Yes, it is. So how LLMs decide what tools do I need to access is based on the description. It's non-deterministic. So as you see here, I haven't asked you to do where a user asks to add, run the add functions. When a user asks you to read them, use this. I haven't defined anything like that. That definition is based on your tool description. So if you're, I can show something very silly. Is your server, so your LLM uses your function names and your descriptions to identify what do I need to do. And I could call this thing, even if I name it to your tool, my agent would get confused and never call this, because why would I call it? There's no intent of calling this, right? So if here, okay. Yeah, so essentially what you could do is add a description here. Your tool name is called a viewer tool, but the description is greet users. What your LLM would do is look at your tool name, the description, the input parameters, and based on that, make a judgment call that I need to call this tool. So yes, 100% you need, as a best practice, to add the description for your tools and input, outputs, and whatnot.
Yes. With that example where you got a remote server with your tool, is that like a hidden tool? So if you knew, did you tell your agent to call that tool?
Yes.
Even though it's not defined?
Yes. So if there's a very specific scenario where you want
like a kind of thing.
Yeah. So you can have, so let's assume you don't know that you know there's a tool called reading. You can guide the LLM agent to call that reading tool first before doing anything. Even though it's not defined on your list of tools, it could be part of the prompt.
And just another follow-up question. I saw that you're running ADK.
Yes.
So how does that fit into the whole picture?
ADK is just an orchestration framework. It's like LangGraph and LangChain and TrueAI and whatnot. What it does is orchestrates this entire thing behind the scene. So technically, your LLMs can't call tools.
Right.
Your LLMs just know that, oh, I need to write a token. That's all it does technically. ADK, LangGraph, and all of these orchestration frameworks, they manage the tool calling for you. So when an LLM says, I need to call greeting, your LLM never calls greeting. It just says greeting with the parameter, that's it. So your ADK, in this case, intercepts that message, calls the tool, and then responds back and passes on to the LLM.
And where do you import that in your code? Like, is it like dependency that you need to?
Yeah, so it's a Python package, and there's a Java version of it as well. So if you look at this, it's from google.adk. So it's a pip install, or Java has a package as well. So you just import that and use that for orchestrating everything. Same for LangGraph, all of those are just packages that orchestrate your model calls. Any other questions? Okay, I'd go into a couple of interesting things about MCP. We saw what's good, but there's a lot of things that don't work. And specifically given it's less than a year old. Oops. Authentication is tricky. You need to authenticate your front users to the agent. Your agent needs to be authenticated to your MCP server. And within the MCP server, each and every tool has to be authenticated differently, because some people should only have access to read versus some people would only have access to write, or wouldn't have that, let's assume it. So everyone would have a different set of tools that they can access. This is tricky. There's no centralized provision where you can map all of your tools with the people who can access it or not. So it's a completely custom setup that you need to run through and figure out what authentication works for your use case. So usually you could have, like as a standard practice, you could have everyone accessing your agent have the same permission. If it's a customer facing, usually that plus you can't expose their data to someone else. So there needs to be a filter that goes in there that, okay, I'm asking for my bank balance, don't show your bank balance. So all of those authentication needs to go in the tool where it filters out what information can I fetch. And it is tricky. It's very, very, when you look at things online, it seems like MCP does everything. No, it doesn't. It's hard. But what it helps you with is make things standardized. So every time you authenticate, it's the same way. It's not different authentication method for every single thing. MCP clients are still fairly new. MCP protocol itself was defined in November, and then as you saw, they started building client support in March, April, May, and onwards. So because they're not super stable, deployments can be hard. And specifically, if your deployment endpoints pickle your connections, then pickling a live connection as a coroutine is not possible. So a lot of times you have to find a way to deploy your remote MCP clients to some specific format. So Cloud Run, you could deploy everything yourself. Fine. Agent Engine, it fails because it can't pickle that live connection. So maybe over time things would get better, but something to know. And this is just a warning kind of thing. Make sure you know what server you're connecting to, just like APIs and everything. Don't just use any random server you find online and use it. They pose a real security risk. You need to have a centralized way on what MCP service should I allow my users to access, because there could be malicious code sitting somewhere because it has all permissions to execute your APIs and whatnot. So be careful what you use. And just to summarize everything here, MCP is not a silver bullet. Everyone thinks MCP is the next big thing. Maybe it is, but it's not going to solve all your problems. You still have to manage authentication. You need to manage scaling. As I talked about data management, who can access what data, all of that still needs to be applied. Like, it's not going to solve your problems. Though it's a good standard format, it's not where you start. If you're building a POC, if you're building a pilot project within your organization, you don't want to think about MCP and whatnot. You can start building your tools yourself, use it within your agent. Once you know there's value in doing it, once you identify that there is a return on investment and you want to move it to production and scale and whatnot, that's when you start bringing in MCP. Or the other scenario is if you're using Cloud Desktop, Gemini CLI, and whatnot, use MCP because you don't want to write tools for GitHub and all of that. It's already out there. You can reuse them. But yes, it's not the starting point, and MCP is still evolving. Yes.
You stuff with skills and how you use this token. So a little bit.
Yes. So there's a small research that some team somewhere in the world tried to figure out what MCP does on the backend, and it turned out that MCP has a context load problem. So what context load means is it adds a lot of tokens in your calls, and every time it calls MCP server, there's an extra bunch of information that flows through in your context. So, sorry, what's that?
You burn too quick.
So you burn through your tokens much more quicker because you have a finite set of token limit anyway. Also, you need to manage those tokens every single time. So there is that problem, which I don't know when it would be fixed. It would be, but skills is more about your local development environment itself. Is you just have your markdown files as skills, which have Python code and all of that in there that you can access. At this point, I can't comment what's better, what not. It's fairly new. I don't know, honestly. I don't have an answer for it. It's just that it's two different ways of doing the same thing. I would have preferred that everything could be an MCP instead of a skill, or skill would be wrapped as an MCP resource. I don't know. We'll find out what's better or what's going to work over time. But skills, for sure, you can't have it as a remote server, as I mentioned. So if you have an enterprise where you want to decentralize tooling and provide access to tools based on different teams, skills might not work because it runs everything there on your device.
I'm just curious, how would you actually have your clients to set up the MCPs, and what kind of use cases that the business come with use internally or externally?
Let me rephrase that.
Just your context.
Yeah. So your question is, when do we use MCP?
Yeah, like when do you actually build the MCP for your client? What is a great use cases?
So I really love this use case where it's decentralizing your agent runtime, right? So, and when you go into a corporate environment, there's so many factors that lead in that a team would only want to control their source of data, their systems, and they wouldn't let you use anything directly. So if you have those scenarios in an enterprise setting where everyone has a perimeter of managing their own tools, then MCP is a really good way to go for that, because a team would just keep releasing their own tools without needing for everyone to go on a schedule and then figure out when it gets updated. It gets updated instantaneously when this team defines the new set of tools or products and whatnot. So that's a really good one. And the other one that I think is local development. I don't want to write all of those connectors myself every single time. I don't want to write GitHub connector and then Google Drive connector. Everything is pre-built. So I can just define these connectors as an MCP client and off I go. Any other questions? There are two on the back. Do we still have time?
Yes. So like all the other so specifically for the open sourcing, like in CNCF, you have a process before any new tool is allowed production ready, right? So it goes through the graduation program before it is actually ready. Do you know of any frameworks or anything specifically around security, considering MCP is open source, that is being developed or is already in place to make sure that the API, specifically calling the APIs, it goes through a bit of governance and sort of
predefined framework wherein the community has put together. These are the sort of things you need to consider or put in place before it is called as mature enough to be used in production.
Not yet. There is no framework around it, because if you go on MCP's own white paper or whatever they call it, it's still, if you look at it, it's still in draft. It hasn't been finalized yet. It's too soon for anything to be finalized, and it changes very often. So until a couple of months back, when I looked at the authentication side of the things, they had an architecture diagram on what they recommended the authentication to look like, but now it's gone. And it's like, you figure it out. So yeah, there's no standards at this point. It's just what works for you. You just have to play around with it. Maybe in sometimes we might have that.
Hey, a few questions, but maybe a comment about authentication and the reason it's not in scope anymore. And you see MCP servers in production, they're not trying to solve authentication. It's just hosts to like websites or REST API or whatever it is. And then the agent is acting just like an HTTP client, passing the mirror together. And so that's why it's out of scope. It's just using whatever views on the web. I have a question, an actual question about prompts. Can you tell us about the MCP prompts? Because by far, it's much more powerful than tools and resources, right? Tools, 98% of MCP tools out there, they are completely redundant. You can replace them by a sub-agent or skill that just knows about CLIs, GitHub CLI. There's no reason using the GitHub, for example, GitHub MCP servers, just using GitHub CLI. Use no accessible context window. But the prompts are extremely powerful, right? Because you can steer through prompt library, you can see the behavior of the boot agent. Can you talk a bit about that? Have you played with it?
I haven't. But what I know of that is, have you played with Claude Code a lot? So if you ask the same prompt to Claude Code versus Gemini CLI, it acts very differently if you observe that. And that is where these prompts come in, because it's written very, very differently. And Claude injects a set of instructions which we don't know where, but it does that. And that's where these kinds of prompt templating comes into the play. I haven't personally implemented any dynamic prompts or prompt versioning, but it's all I know.